We begin now to take a look at a handful of unique shapes. We're going to begin with parabolas and move on to some others, including circles, ellipses, and hyperbolas. And you might be feeling a little bit like, we've already learned about parabolas. It was way back in November, and we graphed them and found x-intercepts and so forth. We did quadratic equations and the functions and axis of symmetry and everything. We learned that ridiculous song. Why do we need to look back at parabolas again? But it turns out that parabolas are part of a group of shape known as conic sections. Parabolas, circles, ellipses, hyperbolas, all part of that group. And we're going to define a conic section this way. It's a figure formed by the intersection of a plane and a right circular cone. And then depending on how the angle of the plane meets that cone, the intersection could be a circle, it could be an ellipse, it could be a parabola, or it could be a hyperbola. And we're going to take a look at all those shapes through the course of this unit. So now, when we think about parabolas, we now have a different way of describing the set of points that are on a parabola than we did before. And it turns out that we're focusing on a point called the focus and also a line called the directrix. So the focus lives on the axis of symmetry, and the directrix is opposite side of the vertex from the focus, and it's also perpendicular to the axis of symmetry. And the vertex lives halfway in between the focus and the directrix. One of the other unusual things as we look at parabolas now is that not only do we have parabolas that can open up and down, we also have parabolas that can open left or right. And we dealt with those when we were looking at functions. That wasn't even on our radar screen. A parabola that opened left or right would not pass the vertical line test, so it wouldn't be a function. So we didn't consider them at that time. But now, as a conic section, we can. And so these are the four possible cases that we have to consider. We could have a parabola that opens up or a parabola that opens down. In those cases, the general form will be x squared equals 4py. For the parabola to open up, p is positive. If it opens down, it's negative. For a parabola opening left or right, we'll flip the x and the y. And we'll have y squared equals 4px. If p is greater than 0, the parabola opens right. If it's less than 0, it opens to the left. So here's a table that you can use, and go ahead and fill this out in your notes. The standard equation, and then how to locate the focus, the directrix, and the axis of symmetry. Now we know that the vertex theoretically could move anywhere around in the coordinate plane. Today we're only going to think about parabolas when the vertex is at the origin at 0, 0. So go ahead and fill this out in your notes. If the equation is x squared equals 4py, the focus is located at the point 0, comma, p. The directrix is going to be the line y equals the opposite of p. The axis of symmetry is vertical. And in this case, because the vertex is the origin, it's going to be the line x equals 0. When we go y squared equals 4px, the focus is at the point p, comma, 0. The directrix is the line x equals the opposite of p. Axis of symmetry is going to be horizontal. And that's, in our case, the line y equals 0. So let's go ahead and try one together. We're going to graph this equation, y equals negative 2x squared. And importantly, we're asked to identify the focus, the directrix, and the axis of symmetry. And so it's a really good idea to keep your table handy at the top so you can refer back. So I've got the equation y equals negative 2x squared. And I look here and I see x squared equals 4py. So I'm going to use that as my form. So now I have negative 2x squared equals y. I want to get this solved for x squared. So let's do that. Divide by negative 2, divide by negative 2. So x squared equals negative 1/2 times y. Okay. Now, again, thinking about this, x squared equals 4py. x squared equals negative 1/2 y. So we can see that 4p equals negative 1/2. So we're continuing trying to solve for p. Divide by 4, divide by 4. So negative 1/2 divided by 4, right? Same as multiplying by 1/4, right? Thinking back to rational expressions and complex fractions. So p equals negative 1/8. Excellent. So now let's identify the focus. So when it's x squared equals 4py, my focus is the point 0, comma, and then whatever p is. So that's negative 1/8. The directrix. That happens at the line y equals the opposite of p, so the opposite of negative 1/8 is positive 1/8, and the axis of symmetry it's a vertical line, and in this case x equals 0. All right, let's try one more. Go ahead and pause the video if you want. Try this one on your own, and then come back and check your work. So if you work through this, negative 1/4 y squared equals x. So let's get y squared by itself. I'm going to multiply the entire equation by the reciprocal, which is negative 4. So y squared equals negative 4x. I can see that 4px and negative 4x are the same. So 4p equals negative 4. And p equals negative 1. So now, my focus. This one is a horizontal axis of symmetry. My focus is at the point p, comma 0, so negative 1, 0. The directrix, x equals the opposite of p, so x equals 1. And then my axis of symmetry is y equals 0. So let's go ahead and graph this now. My focus is at negative 1, comma 0. My directrix is the line x equals 1 and the vertex at the origin. So we need some points here. And so we go ahead and we plug in some values for x, and this one's operated in such a way that I'm really trying to plug in some y's here and get some x values out. So let's see what happens when we plug in some y's. Okay. So if I put 2 in for y, 2 squared is 4 times negative 1/4, that's negative 1. If I put 1 in for y, I'm going to get 1/4. If I put 0 in for y, I'm going to get 0. Similarly, negative 1 squared is 1, negative 1/4, and negative 2 squared is 4. I'm going to get negative 1. So let's go and plot those points. Negative 1 happens at y equals 2, and y equals negative 2. X at negative 1/4 happens at y is negative 1 and positive 1. And so we've got a parabola that kind of sits on its side, right, from what we're used to seeing. Okay? The focus and the directrix. Every point here is equidistant between the focus and the directrix. So that is graphing a parabola as a conic section, identifying focus, directrix, and axis of symmetry. So make sure to go ahead and kind of cement your thinking, cement your learning here. Go ahead and take some time to look back at what we've done today. Write down 3 things that you learned, 2 things that you want to know more about, and then 1 big question that you still have, and then the space here below. for additional note taking, and that could be sketches, it could be other connections, random thoughts that you have.